So hello once again everyone. By the way, this is Mr. Ondos again reporting for the solutions of systems of linear equation. So what is this topic all about? So let us recall that the set of all solution vectors of the homogeneous linear system Ax is equals to 0, it is a subspace. The set of all solution vectors of the non-homogeneous system Ax is equals to B, where B is not equal to 0, is not a subspace because the 0 vector is never a solution of a non-homogeneous system. There is a relationship, however, between the sets of solution of the two systems Ax is equals to 0 and Ax is equals to B. Specifically, if x sub b is a particular solution of the non-homogeneous system Ax is equals to b, then every solution of this system can be written in the form x is equals to x sub b plus x sub n. Where x sub h is equals to the solution of the corresponding homogeneous system Ax is equals to 0. The next theorem states this important concept. So what is this theorem? That is Theorem 4.18, Solutions of a Non-Homogeneous Linear System. If x sub b is a particular solution of the non-homogeneous system Ax is equals to b, then every solution of this system can be written in the form x is equals to x sub b plus x sub h, where x sub h is a solution of the corresponding homogeneous system Ax is equals to 0. So an example is finding the solution set of a non-homogeneous system. Find the set of all solution vectors of the system of linear equations. So as we can see on the equation below, x sub 1 minus 2x sub 3 plus x sub 4 is equals to 5. 3x sub 1 plus x sub 2 minus 5x sub 3 is equals to 8. X sub 1 plus 2x sub 2 minus 5x sub 4 is equals to negative 9. So solution. The augmented matrix for the system Ax is equals to B reduces as shown below. For the first row, we have 1, 0, negative 2, 1, and 5. Second row, 3, 1, 3, 1, negative 5, 0, and 8. For the third row, 1, 2, 0, negative 5, and negative 9. And that is 1, 0, negative 2, 1, 5, 0, 1, 1, negative 3, negative 7, and 0, 0, 0, 0, and 0. The system of linear equations corresponding to the reduced row echelon matrix is x sub 1 minus 2x sub 3 plus x sub 4 is equals to 5. X sub 2 plus x sub 3 minus 3x sub 4 is equals to negative 7. So letting x sub 3 is equals to s and x sub 4 is equals to t. So ato siyang i-let ang x sub 3 into s and x sub 4 as t. So what is the next thing that we're going to do? We have to write a representative solution vector of Ax is equals to b. So as shown below, x is equals to x sub 1, x sub 2, x sub 3 is equals to 5 plus 2s minus t, negative 7 minus s plus 3t, 0 plus s plus 0t, plus 0 plus 0s plus t, and that is equals to 5, negative 7, 0, 0 plus s, 2, negative 1, 1, 0 plus t, negative 1, 3, 0, and 1. And that is equals to x sub b plus su sub 1 plus tu sub 2. X sub b is a particular solution vector of Ax is equals to b, and x sub h is equals to su sub 1 plus tu sub 2, and represents an arbitrary vector in the solution space of Ax is equals to 0. So in Theorem 4.19, that is the solutions of a system of linear equations. The system Ax is equals to b is a consistent if and only if b is in the column space of A. So example, consistency of a system of linear equations. Consider the system of linear equations. x sub 1 plus x sub 2 minus x sub 3 is equals to negative 1. X sub 1 plus x sub 3 is equals to 3. 3x sub 1 plus 2x sub 2 is equals minus x sub 3 is equals to 1. So the solution for that is the augmented matrix for the system is AB is equals to 1, 1, negative 1, negative 1. Second row, 1, 0, 1, 3. Third row, 3, 2, negative 1, and 1. A sub 1, A sub 2, A sub 3, and A sub 4. So the reduced row echelon form AB is equals to 1, 0, 1, 3, 0, 1, negative 2, and negative 4, and 0, 0, 0, 0. So there are infinitely many ways to write B as a linear combination of the columns of A. And makita nato nga ang B is equals to 2A sub 1 minus 2A sub 2 plus A sub 3. So, B is in the column space of A and the system of linear equations is consistent. So, the summary below represents several major results involving systems of linear equations, matrices, determinants, and vector spaces. So, if A is an n times n matrix, then the conditions below are equivalent. First, A is invertible. Second, AX is equals to B has a unique solution for any nx1 matrix B. And third, AX is equals to 0 has only the trivial solution. And the fourth, A is a row equivalent to I sub n. Fifth, A is not equal to 0. Sixth, rank A is equals to n. Seventh, the n row vectors of A are linearly independent. And eighth, the n column vectors of A are linearly independent. So those are the summary that represents several major results involving system of linear equations, matrices, determinants, and vector spaces. So those are all of the reports, or that concludes the report of our group, and I hope that all of you have learned something for today's discussion, and I hope that the lessons that you have grasped during our discussions will be applied to our future, and we can apply it in ourselves, especially in solving real life situations. And as future educators, I am encouraging each one of you to just continue, keep on striving, keep on dreaming. Padayon lang yun ta mga future educators, because that is our biggest foundation. Our education is our biggest foundation, and we will serve as a next or the future educators to the young ones, to the ones that have juvenile minds. So once again, thank you very much for listening, and this has been the group 4 reporting. Thank you.